Hello everyone, this is video recording for visually impaired students from the Pradeep's Physical Chemistry. Today we will read about the topic gels. Article 7.11.1 Definition. Some lyophibic salts, example that of gelates or agar-agar or gum arabic etc., containing high concentration of the dispersed solid on cooling change spontaneously into semi-solid form, that is jelly-like, enclosing the entire liquid within it. The product thus obtained is known as gel and the process is known as gelation. Similarly, some lyophobic salts, example that of silicic acid and ferric hydroxide etc., which show some lyophobic character, also form gels under suitable conditions when electrolytes are added into them. The colloidal system, and considering the liquid as the dispersed phase and the solids as the dispersion medium when present in a semi-solid state such that the entire liquid is enclosed within the solid, is known as gel. It is believed that a gel consists of a three-dimensional network formed by linking and cross-linking of molecular chains of the solid's dispersion medium within which the liquid of the dispersed phase is enclosed. Article 7.11.2 Methods of preparation of gels. Depending upon their nature, gels may be prepared by any one of the following three methods. First, by cooling the sol. When a lyophibic salts such as that of gelatin or agar-agar etc., prepared in hot water and containing not too low concentration of the solid, is cooled, it is transformed into a gel. This is because as the salt cools, the dispersed particles undergo hydration. As a result, they lose their stability and agglomerate together to form larger particles in the form of semi-rigid structure within which the entire liquid is entrapped. Second, by double decomposition or metathesis. Some hydrophobic gels such as that of silicic acid and aluminium hydroxide, commonly known as silica gel and alumina gel, are prepared by this method. For the preparation of silica gel, hydrochloric acid is added to the aqueous solution of sodium silicate. As a result of the double decomposition reaction, free silicic acid is produced. It is highly gelatinous due to hydration and on allowing to stand rapidly sets to a solid gel. Similarly, for the preparation of alumina gel, sodium hydroxide solution and aluminum chloride solution of suitable concentration are mixed. The hydrated aluminum hydroxide formed on allowing to stand sets to a solid gel. Third, by change of solvent. Some gels are formed by dissolving the substance in one solvent and then suddenly changing the solvent in which it is insoluble. For example, a gel of calcium acetate is obtained by this method. For this purpose, calcium acetate is dissolved in water so that the concentration is not too low and the alcohol is rapidly added to it. As a result, the salt is thrown out of the solution as a colloidal dispersion, which on keeping sets to a solid gel, within which all the liquid is entrapped. Article 7.11.3 Classification of gels. Gels are classified into elastic and non-elastic gels. The main points of difference between the two are as follows. Elastic gels. First, these are those gels which possesses the property of elasticity. That is, they change to solid mass on dehydration, which can gain to be converted into gel by addition of water followed by heating and cooling. When placed in contact with water, they absorb water and swell. This property is called imbibition. Examples include gelatin, agar-agar, starch, etc. Non-elastic gels. These are those gels which do not possess the property of elasticity, that is, they change into solid mass on dehydration, which becomes rigid and cannot be converted into the original form of heating with water. They do not show the phenomena of imbibition. Most common example is silicic acid. Article 7.11.4 Properties of gels. First, synthesis. When the gel, elastic or non-elastic, is allowed to stand for a long time, it shrinks and loses the entire liquid held by it. This shrinking of gel is termed as syneresis. Second, thioxotrophy. Some gels, like that of gelatin, on mechanical shaking, lost their semi-solid gel-like character and change into a liquid sol. This sol, on standing again, changes into gel. This reversible phenomena involving gel-sol transformation is known as thioxotrophy. Third, imbibition. When a gel is placed in a suitable liquid, it absorbs a large volume of the liquid. The phenomenon is called imbibition or swelling. The effect of the presence of salts on swelling was studied by Hofmeister in 1891. He found that for the salts of the same cation, the effect of the certain anion was to inhibit the imbibition, while that of the certain other anion was to favor the imbibition. For example, in case of iodides, the swelling is so high that the gel disperses into sol even at room temperature. In other cases, the sol is formed by warming the swollen gel. The order of the temperatures to which the gel must be heated in the presence of various anions before it changes into sol is called Hofmeister series or lyotropic series. Greek lyotropic means change to liquid. The order is same as for salting out discussed earlier, that is citrate 3 negative, then tartrate 2 negative, then SO4 2 negative, then PO4 3 negative, then acetate, then Cl negative, then NO3 negative, then Br negative, then I negative, then Cs negative. The anion from citrate to acetate inhibit the imbibition, while from Cl negative to CnS negative favor the imbibition. Thank you.